Welcome back. Continuing from the last video, we are going to talk about the four quadrants, the four quadrants in the unit circle. All right. Now, quadrant is just a fancy word to say 1/4 of a circle or 90 degrees. So we start just like how we start naming, how we start the angle from the 3 o'clock position on a circle. Right, so this would be our first quadrant. First quadrant. And therefore, this side will be the second. Right, it's just like how we go around the circle. Third quadrant is here. Oh, so no R there. Quadrant. Last, fourth quadrant. That's just to tell you the different parts of the circle if you break it into 4 parts, right? Nothing else. That's what it means. All right. So what's so special about each of the quadrant? We're going to investigate. So, for example, we know that. If you remember from our previous video, we know that sine theta give us the y value. All right, give us the y value on the dot, on the point, and cosine theta give us the x value of the point. So coming back to here, so we can conclude, because we got this side of the graph, this side of the circle. The x is all positive, right, in the first quadrant, right? And the cosine and the y value, right? So this is the y value. This is the y value. This is the x value. All right. So in this first quadrant, both the y value and x value, they are all positive. All right. So we know we can deduct, just like Sherlock Holmes. Oh, lately I've been watching Sherlock Holmes. I love the show. Go Benedict. Go Benedict. All right. Okay, enough. So we know in the first quadrant that both x, y, and y, all the x value and y values are positive. So therefore, cos. Oh, I should use the same color pen. So cos theta, all right, given that theta is between 0 and 90, which is in the first quadrant, is all positive. So I'll write it down somewhere. 0 is less than theta is less than 90. It's positive. Alright? It's squishy there. And same as the sine. Given that theta is less than 90 and bigger than 0, it is positive. So any sine theta, or sine of any theta between 0, sine of any angle, any angle between 90 and 0 is positive. All right, what we're left with tan. Now, because tan is equal to y over, so tan theta, also tan in this case, tan theta, put it theta, is equal to sine theta over cosine theta. And cosine theta and sine theta is just equal to y, and cosine theta is just equal to x. So literally, tan theta is just equal to sine over cosine y over x. And since both y and x are positive in the first quadrant, therefore tan theta, given that theta is an angle between 90 and 0 degree, is positive. Right? So since everything in the first quadrant is positive, right, given that may it be sine theta, cosine theta, or tan theta, as long as the angle of the theta is less than 90 and bigger than 0, it is positive. So that's why we call this quadrant all. Give it an A for all. Yeah? So that means everything in here, in the first quadrant, may it be cosine, sine, or tan, they are all positive. Alright? Let's look at the second quadrant. Now the second quadrant, the x on this side is negative on the Cartesian plane on the left. So because the 0 is here, right? The 0 is in the middle. So on the left hand side of the Cartesian plane will be negative x value. So x is equal to negative. Correct? And then therefore cosine theta, given that given that theta is between 90 and 180, is negative. Right? It's a bit squishy here. Let me see if I can move the whole thing to the right. Okay, hold on. All right, I have fixed the position of the unit circle. Okay, so there we go. X is negative on the second quadrant, so therefore cosine theta, or cosine angle, if the angle is between 180 and 90, the cosine of that particular angle will be negative. Right? Simply because all our x coordinates on that side, on the second quadrant, is negative. Right? But on the other hand, the y coordinate on the second quadrant will remain as positive. Yeah? So y is positive. So therefore, sine theta, given that theta is less than 180 and bigger than 90, it's positive. Right? Last one, tan. Now, we know that tan is equal to y over x. Correct? Now, given that, so it will equal to positive value over negative value. Oops. Should use a black line here. Over negative value. So the final product would be the negative value. Oops. Final product, since positive divided by negative will give you a negative value. Right? So therefore, tan theta, given that theta is less than 180 and bigger than 90 degrees, is negative. All right? Yeah? So since we only got since sine theta is only positive here, we specially named this quadrant S for sine. So this second quadrant is called the sine S quadrant. All right, just write an S there. It's the S, bigger S. Ooh yeah, S quadrant for sine. Right, let's look at the next one. The third quadrant. Alright, hopefully you guys start to see the patterns here. Alright, the third quadrant, first we have the x value remain as negative because it's still on the left hand side of the Cartesian plane, right? So therefore, x is equal to negative, or the x values are negative. Therefore, cosine theta, given that theta is less than 270 and bigger than 180 degree is negative. All right, but our sign this time is no longer positive. The sign here, the y value here in this region is negative. So y is equal to negative. Therefore, cosine theta, given that theta is less than 270 degree and more than 180 degree, is negative. Right, but for tan, there's a good news for tan, right? So tan theta, also tan is equal to y over x. Yeah, and so sine over cos, yeah, and in this case, they are both negative. So it's been negative over negative. Right? So that our end product, our final product will be a positive. Right? Negative divided by negative gives you a positive answer. So that is why in the third quadrant, tan theta, given that theta is less than 270 degrees and bigger than 180 degrees, will be positive. Right? So that's why we call the third quadrant a big T for tan. Yeah, a big T for tan. So I just write it in there. We've got the A here. We've got an S there. Now, can you guess what's the last one? Right, most of you should be able to guess. All right, when it comes to the fourth quadrant, all right, our x value has finally returned to positive. So x is equal to positive. All the x values are positive. Therefore, for cosine theta, given that theta is less than 360 degree and bigger than 270 degree, is positive. All right, and then y, in this case, the y value is still negative. So y is negative. Right, therefore, sine theta, given that theta is less than 360 degree and more than 270 degree, would be negative. Almost said positive there. Whew. And now in tan, as for tan, since tan is equal to y over x, right? Therefore, in this case, will be negative over positive. And we know that will still give us a negative value. Yeah, a negative value divided by a positive value will still give you a negative value. So therefore, tan theta, given that theta is less than 360 degrees and more than 270 degrees, will be negative. Right? Given that out of sine, cosine, and tan, only the cosine value in here in this particular quadrant is positive, we will call this quadrant C. Big C, yeah? A big C for cosine. So there we go. That's the fourth quadrant, and that and each of the sine and cosine and tan and what they are in that particular quadrant. All right, so that's it. Whew. The next thing we're going to talk about will be the symmetric feature of the unit circle.